What up, everybody? Welcome to another episode of Coffee Hour, electrical exam prep here for the month of January. So thanks for joining me. We're almost at the end of the month. A couple more days to go. But again, thanks for joining me at 8 a.m. here, our normal time, which is Tuesday through Thursday. Tuesday through Friday. And then, of course, Monday we have that special time. So make sure you note that, everything. So good morning and welcome. As always, give me a shout out. Let me know where you're from. Adam's got his coffee. He's ready to roll. So again, let me know where you're from and what you're all about, and whether you're a student or not in your program or not. Don't have to be to join us every morning. And we're streaming on multiple platforms. So I think there's 9 different platforms that we're streaming on at the same time. So Rumble, Instagram, over on Fast Tracks Tube, on two YouTube channels, two LinkedIn channels, and of course 2 Facebook channels. So again, thanks for joining me. And Paul, good morning from down in Houston. Charlie, got my regulars here. Charlie, thanks for joining. Good morning, David. Thanks for joining me. Dominic, thanks for joining me. So again, all of y'all, thanks for joining me. Let me know that you're here for that morning drive. So, all right, I got my coffee. Hopefully you've got yours. I'm sporting just a donut house blend today. Just a plain old donut house. K cups from Costco. There you go. I'm a big Costco guy. So anyway, thanks for joining me. So before we get started in today's, looking at some exam prep questions and going over them, and we're going to be finishing up the database, exam question database 16 that's in our program. So if you're wondering where the questions for the last week have come from, they're coming from the database 16 in the program, in case you want to go back and look those over yourself. What's up, Crypto? Thanks for joining us. Red Dog is in the house. Buenos dias, Los Angeles. Got that coffee brewing. What's up, Rob? Over on Fast Tracks Tube. Thank you, Rob. David, joining us. Good morning. Thanks for joining. All right. So first thing I want to talk about before we get into exam prep questions, I want to talk about a little bit about voltage drop. As somebody that handles a lot of these questions about voltage drop for manufacturers and being in the wire and cable business and understanding voltage drop, and also understanding that there is a big discussion amongst manufacturers of wire, all fairness, to talk about what efforts need to be done in order to get voltage drop into the NEC, a little bit different than what it is now. Now, I know what you're saying right off the bat. You're thinking, there you go. It's those manufacturers just trying to get voltage drop in there, so you have to increase the size of the conductor so they sell more copper. Look, it's certainly not the effort. But our goal is to always look at the way conductors are used and the safety of how they're used and the heating effect on them and all these type of things. That's constantly our goal. That's what R&D does. And for example, with Encore Wire and Prismium, it's a much larger, probably the world's largest wire and cable manufacturer now. It's a very big concern for us to look and make sure the conductors, the insulation is adequate, that it's going to be held up to different types of exposures and all that kind of stuff. But let's talk voltage drop from an exam prep perspective versus in the field perspective. And of course, if you have any questions, feel free to put them in there. In fact, I'll go to the chat page while I'm talking. Frank, thanks for joining us. Just so I'm talking, so I can capture anything that you might want to ask about voltage drop before we go into some questions and dissection today. Just drop a little bit of knowledge on you about voltage drop. So on TikTok, Instagram, Facebook, a lot of all these things, and of course it was highlighted by Angry Sparky the other day, texted me out that somebody asked him about voltage drop. And when he explained voltage drop to him, and he knows it very well, it went from, let me ask you about it, to cussing him out, like he didn't know what he was talking about. So it's like, you always have to do voltage drop. Now, one thing to remember about the voltage drop is that the whole goal here is from point A to point B. We want to make sure that at the end result, that we have the level of voltage necessary to be adequate to supply whatever it is we're trying to supply, whatever utilization equipment, whatever piece of equipment, whatever motor, whatever we're doing. What's up, TJI? Thanks for joining. So the whole concept, and he's over on Facebook, Fast Tracks Tube. Gotta love that. All right, so more and more people using that. Let me know what you think of it and the whole platform. So the goal is to make sure our voltage is adequate and it doesn't drop below what is recommended. Now, there's a big misconception when it comes to voltage drop out there. Now, sensitive electronic equipment has its own rules for voltage drop, and so do fire pumps. The whole reason fire pumps have a voltage drop is because, again, you're sizing everything so that you really don't have any overload protection is the way you're sizing stuff. And we want the motor to just burn up. So we want it to keep running, right? And so we want to make sure that voltage isn't an issue at that fire pump motor and accessories. So it's important to make sure that we stay within the parameters that are given to us within the fire pump application, 695 article. Okay, given. Sensitive electronic equipment can operate at voltages, whereas if it's outside of the voltage range of a sensitive electronic equipment, it could affect its operation. So it gives us its own voltage drop. Those are requirements. Okay. Anywhere else in the National Electrical Code currently, when it comes to any general application, general installation, there is no voltage drop requirement. There are voltage drop recommendations that are contained in what we call informational notes. Now, informational notes in the code, it'll say informational note. That is exactly what it is. It's just information. It used to be fine print notes, but that sounded more like legalese, and it made people think, well, I've got to enforce this. And it made it harder because it meant inspectors were looking at it going, I've got to enforce this. That wasn't what it was supposed to be. It was just supposed to be really good information. And I'm a big fan of the fine print notes that are now informational notes. I'm a big fan of them because they can help maneuver you through the NEC. If we do it right, it gives you references to other areas in the code to make you go, let me go look at that. There's been a big effort for the code panels to try to reduce the number of informational notes. I would disagree with that, even though we want to make sure that the National Electrical Code is not an instruction manual, because it's not that, but it does have instructions, and it's becoming more of closer to an instruction manual than it used to be years ago. It's just, pure code, right? So it's changing, evolving, not to take the place of the manufacturer's instruction. What's up, Eric? Thanks for joining me. TGI says he loves Fast Tracks Tube. Awesome. Well, we're expanding that sucker out. So thank you for being over there on it. And we're going to keep adding to that because I believe that is the integrated videos. TJI, have you checked out the interactive video yet? Have you done the gamification thing yet for the interactive video for the closed closet lighting and all that? That's a video. That was our test video. We got more that my team is working on for that, but that was our test dump to see what people thought of that interactive video. Of course, you can click play and watch the whole video and skip the interaction part if you want, but why would you do that? Anyway, so that's under videos. You'll see where it talks about interactive videos if you go over to Fast Tracks 2, by the way. Let's see. What else we got? Samantha in the house from Richland, Washington. And again, good morning, David. Glad to have you here. All right, so voltage drop again. So a couple things to remember about voltage drop. Is voltage drop for an exam prep something that's liable to be on an exam? Yeah. And people really hate that because they say, voltage drop is not a requirement unless you're asking me a question about sensitive electronic equipment, or you're asking me something about a fire pump. Why the hell would you ask me something about voltage drop? Well, that typically falls under that realm of where they feel like you put in some time, right? You put in a certain amount of time to qualify for your license. A lot of the states and a lot of the PSIs and all that want to ask you some knowledge-based questions that you won't find in the National Electrical Code. Now, the reason I'm bringing this up, because again, I got some emails from people about this, so I wanted to dedicate this, and I told you yesterday at the end of the show that I would be bringing up a topic today, and that's what I'm talking about. We're talking a little bit about voltage drop. We'll get into some questions, but so voltage drop can affect the operation of certain equipment if it doesn't operate within its range. Hey, what's up, Oscar? Thanks for joining. Out in Los Angeles. Thanks for joining us this morning. Got your cup of coffee, chilling out before you head out. It's early out there in Los Angeles for you guys and gals. So thinking about voltage drop from a design perspective, is it a good idea? Yes. And y'all know it's 3% on the branch, 5% overall. So we could have a 2% on the feeder, but it's 3% on the branch. You're going to find that recommendation in 210. You're going to find that in 215 recommendation. You're going to find that in 230 recommendations. You're going to find that in various areas of the code where they make a recommendation for voltage drop. So at the end of the day, it's a really good design. For an exam prep question, they typically going to ask you a voltage drop with specific variables, right? And so they're going to be talking about it. And they're going to be talking about what's the formulas for voltage drop. So I tell folks all the time, thank you. So I tell people all the time, be familiar with the formulas. And that's all you have to be familiar with. And sometimes you can, if you're in an exam location where you can write these things down in your code book, if you're in a state that lets you write in your code book, then you want to write formulas down, okay? So one of the things that we would write down, okay, would be voltage drop. Okay, so here, if you look at examples over here, you'll see here's some examples of voltage drop. Okay, 2 times K times I times L divided by circular mil is going to give you the actual voltage drop. Okay, 2 times K times L divided by the actual voltage drop. That is the actual volts, mind you. Right? So, for example, for a 120 volt circuit, then y'all are familiar that it's going to be 3.6 volts. So that's what the voltage is. You use the actual voltage, right? And just take a look at this screen just for a second. And then, of course, if you know the circular mils of your conductor and you want to find out based on your length. So 2 is for single phase. Remember, if it's 3-phase, replace the 2 with the 1.732. It's just that simple. And these are basic foundational formulas. It can get deeper with power factor and all this kind of stuff, but not really necessary for an electrical exam. This is really about as detailed as you need to get. And of course, depending on what you need to know. Now, if you know these variables, you know that 2, again, is single phase. You replace the 2 with 1.732 for 3-phase. The K. Now, the K is called the constant. Now, rather than have to figure out how to calculate out the actual K, which, again, you see here, that gives you instructions on how to do that. And we actually have a card that you can carry in your pocket that does that. It's really not necessary. If you just take aluminum conductors and substitute the K with 21.2, and when it comes to copper conductors, the K you can substitute with 12.9. Okay, just kind of lock those in your brain. And then I is obviously the symbol for current, which is amps. And you need to know the amps accurately, right? And then, of course, you have L, which is the length. That is one way, right? That is only one way. Okay, that type of thing. And then, of course, if you want to find what the maximum length for a specific voltage drop value, okay. So there, in this scenario, is circular mills times, the voltage drop. Solve that first, divided by, and then solve the parentheses, 2 times K times I. So kind of I, remember the I as current, remember the L as length one way. VD is always going to be the actual volts drop, not the percentages like 3%. It's the actual volts, okay? Like if it's 240 volts, it's 7.2. If it's 120, it's 3.6. That type of thing. Circular mill is maybe you already have a conductor in play and you want to, and you know what to say, it's a 500 kc mill, then that's where you would plug in the actual circular mill. So just kind of giving a glance at this is kind of screenshot or whatnot, and make sure you keep getting a good idea of the different formulas that you may use. Right. So that's just kind of wanted to talk about the different things for that. So let's come back to chat in here. And Rodman's offering recommendations. He's saying, have you ever thought of posting these videos for 24 hours after making? The videos are available immediately after we make them on YouTube and all these platforms that are streaming on. They're automatically available. We have not added it to Fast Tracks Tube yet, but they will be. They'll be in their own category and very shortly. We just haven't done it yet. All right, we're giving it time for people to absorb them. This is new, and so we want it to be seen on all the platforms, and then we'll slowly move them off of those platforms, and it'll be in a special series called Coffee Hour. And it'll be a special series over on Fast Tracks too. But we've already thought of all that. We just are not ready to do that because we want everybody to be able to replay them and rewatch them over on the platforms to which they're viewing on right now. That type of thing. Okay. And we just have not done it yet for Fast Tracks 2. All right. But they will be. They'll be over in their own series platform. The difference is on Fast Tracks Tube, we don't want to replay them for free. We want them to be replayable to members. Okay, so that's why we're giving everybody a sample on all the platforms, and then eventually that'll all move to the Fast Tracks 2. And then you have to be a subscriber. So there's a method to the madness, Rob. We just haven't gotten there yet. Good morning, Manny. Thanks for joining me. All right. Charles says he watched a rerun yesterday. Usually hopefully we put a date up in the top left. And that kind of tells you the day. So we're only going to do one coffee hour in the morning. So anything other than that, usually at 5 o'clock, that would be a replay, that type of thing. So, but you know what? If you watched it again and it took you a half an hour to realize it was a replay, then that's pretty damn good. I'm just saying, I engaged you enough to realize that, wait a minute. And then you realize, oh, this is a replay, that type of thing. Okay. All right. So voltage drop again. Let me end out this voltage drop thing real quick. So highly recommended, not required. So on an exam, it doesn't matter whether it's required or not. If they ask you to do a voltage drop calculation, you do a voltage drop calculation. And you use whatever values that they give you. In the real world, voltage drop is a real deal. It's a real thing. And so I recommend you to take it into consideration. Not just because I make wire and cable, not just because I work for a manufacturer that makes wire and cable. I can already hear that in the comments on whatever social media platform that this is going to be viewed on later in replays. Oh, sure, he would say that. He's a wire guy. He's a cable guy. Whatever. Okay. So anyway, got that out of the way. It is a correlation to the distance. A distance is going to affect the voltage. In turn, the voltage at that level, if you take the voltage at that level, right, and you do a calculation on the amps, you'll see that there's a correlation. The amps can change. So the voltage changes, the amps change. It's all part of the Ohm's law, Watt's law, all this kind of stuff. So it can have a cumulative effect on a long run of a circuit. I was asked the other day, Paul, what is the voltage drop percentage on a 450-foot run, a 500 kc mill? And it gave me all this stuff, and they said, we don't want to use the calculators. We want to know what's your answer. And I said, well, I can't really give you the answer. And they said, why? I said, well, it's aluminum, 500 kc mill. It's 310 amps. Are you telling me that the load at the end is 310 amps, which is rare to fill the full load of the conductor's ampacity. And he said, yeah, it's 310. Okay, then we can solve it. So it's important with the accurate voltage drop calculation that you have all of the variables. Otherwise, they're not going to give you an exam question that's not going to give you the variables, right? You might have to do some math to get some of the variables, but I need to know what the amps are at the end of the run, okay? And if I don't know, I'm just going to take the default, right? If it's if I'm sizing a conductor based on, let's say it's a 100 amp overcurrent device protecting a feeder, and you're telling me, and you don't tell me what the actual load is on it, because I'm sizing the conductor originally based on the overcurrent device. I'm protecting the conductor. I do voltage drop if I'm going to do it. You always do that last. Always size the conductor for the load first. Size it. Once I've established the conductor size and that I'm protecting it with an overcurrent device, okay, whatever size it is, overcurrent device, once that's done, then I will look at voltage drop. And it may jack the conductor up, but it's still going to be protected at its ampacity. All I'm doing is jacking it up because of what? Voltage drop. And so that's the beautiful thing about understanding that voltage drop is not a requirement. Meet the requirements of the code first. And then you can apply and see if that conductor is still adequate for voltage drop situation. Okay, so that's the mentality that you have to go through. Do everything you're supposed to do first to protect the conductor, the ampacity. Do everything you're supposed to do. And then if you're going to apply voltage drop, then look and see whether or not the conductor itself is adequate or you need to change. Another thing about voltage drop that I hear people talk about is, can I go from a smaller conductor, splice it to a bigger conductor and run it its length and then splice it back down to a smaller conductor to go to the load? And the answer to that is yes. The voltage drop is only about the span. If you still have a smaller conductor, it's connected to a bigger conductor, that's fine as long as the overcurrent device is there to protect the smaller conductor, not the bigger conductor, okay? And so that's, municipal inspectors have a fit with that one, that type of thing. Let's see here. We got some things here on the scene. Red Dog says, I just watched the pipe fill webinar. I missed Fast Tracks 2. Yep, there you go. Started watching 8-hour calculations on here. Fast Tracks 2, pure class, until I ran out of coffee. Well, you need to make sure you just put your pot right beside you. And but you do know there is a pause button, Adam. Okay, I'm just saying. All right, let's get to some exam prep questions. That was just a little discussion on voltage drop. If nobody has any real questions on voltage drop, if something comes to mind, go and put it in the comments. But remember, the K is what everybody gets confused with. K for aluminum, 21.2, and copper, 12.9. Okay, just remember those numbers for K, and you don't have to work it out. One day I might show you the process of how to work it out, that type of thing. Charles says, can you use 90-degree connectors to either go up or down to the largest market in long runs? Well, you want to make sure that if you're talking about, can you use 90, I guess that's 90-degree connectors at either end of a large. You can, but I don't know what you're trying to achieve. So very rarely ever going to find 90-degree terminations. Usually it's going to be 60/75. If everything in a run is rated 90, then you can use the ampacities from a 90 if everything is rated at 90, that type of thing. It does no effect on voltage drop when it comes to starting with a smaller conductor, could have a 90-degree rated insulation, slices onto a larger conductor, right? Could have 90-degree rated insulation, probably will, and then it drops back down, that type of thing. You're still going to be limited, right? Because 90 is only used for adjustment and corrective purposes unless everything in the entire run is rated 90. Well, even if you're sizing the conductor larger for voltage drop, yeah, it might carry more current, but that has nothing to do with the fact you got a smaller conductor that's not going to carry the same amount of current, okay? So that would be, you can always use a bigger conductor, okay? You just can't go smaller. But you got to be very conscious of how you're protecting the conductor, the weakest link concept, that thing. But as far as lugs and terminals, I have yet to see standardized lugs 90-degree rated in enclosures on devices, things like that. So some bus bars are 90 because they don't have a limiting factor, that type of thing, okay? I hope that answers your question, Charlie. Frank says voltage drop is for every wire raceway size with amps, lighting, power. How about low voltage? Cat 6. I don't think that the voltages are as big a deal in the codes. Really, again, voltage drop's a recommendation anyway. So using something on low voltage or even Cat 6 or 5Es or something like that, typically there's the voltage range is not something, but you could have a design engineer that knows that stuff very well and might impose something when it comes to voltage drop on that, but it's kind of tougher for those type of things. Now, you say low voltage, you know that 600 volts is low voltage, 1,000 volts is low voltage. So you mean low voltage? Really nothing in the NEC that's going to drive that, except for maybe some of that. Well, I wouldn't think sensitive electronic equipment because that's just going to be regular voltage ratings and regular stuff, that type of thing. But when it comes to voltage drop, it's all about the circuit. Okay, what you need at the end of the load. That's what it's really all about, that type of thing. I'm sorry, Charlie. I still don't understand the question. I don't know where you're getting the 90-degree rated lugs. They typically are not 90-degree rated on an overcurrent device. So it's a limiting factor. Again, if everything is 90, see, don't confuse voltage drop. It's not a code requirement. Get it out of the mind. Get it out of the mind. It's not a code requirement. So if my lug is 90, my wire is rated 90, the other's rated 90, then I can use the 90-degree ampacity. If I got a smaller conductor and it's a 90 lug, I can use the 90-degree ampacity for the small conductor. The bigger conductor, I can't use the elevated 90 amps for that. Why? Because the smaller conductor is going to restrict it down. I have to protect that small piece at its ampacity. So even though I have a bigger conductor between it, I'm not going to be protecting it at its ampacity. But if I go from connection lug to lug and everything is rated 90, then I can use the 90-degree ampacity. There shouldn't be any problem, that type of thing. It's all about the lug and then the rating of the conductor. Hopefully that answers your question, Charlie. If not, go in deeper and give me an example over at paulabernathy.com if I'm not answering that question properly for you. All right, let's go to some questions. All right. So here we go. Hold on here. Let me get stacked up here. All right. So the area, get your code books out. Let's go. It says the area at a motor fuel dispensing facility. Ding, ding, ding. Okay. Again, remember picking out the targets, trigger words, things like that. Motor fuel dispensing facility within 18 inches of the finished grade and 20 feet from the outdoor gas pump is a blank location. Is it Class 1 Division 1, Class 1 Division 2, Class 2 Division 2, Class 2 Division 2? Okay. So first of all, typically when I'm looking at this, hold on, somebody's bugging me. When I'm looking at this, first thing I'm thinking, I can eliminate a lot. So I can make this a 50-50 right off the bat when I look at a question like this. Because I know that Class 1 locations deal with what? Fuel, liquid, okay, vapors, okay, things like that, right? So I'm looking at it and I'm going, okay. So first of all, I'm looking at it and I'm going, okay. So first of all, I know it's a Class 1 location. So immediately I've eliminated two answers here. Class 2, both of those at the bottom. So it's either a Class 1 Division 1, Class 1 Division 2. The next thing that I'm going to train my mind to do is when I look at a question like this, I'm going to think, is the hazard right there at the dispensing? Where's the hazard at? Because we know that Class 1 Division 1 is going to mean it's evident that the issue's there all the time, okay? And you're right on top of it, okay? It's a everyday issue. Division 2, it says, is it at an area that's less stringent? Is it area away? Is it a little bit away from the pump? Those type of things. It's not as imperative as right at the pump where the fuel's coming out. You get what I'm saying? I try to analyze the question, but we know it's a motor fuel dispensing facility, and we know that that's a defined term in the NEC. Okay, define an actual article in the NEC. So for us, we're going to go look. And John says Class 1 Division 1. Okay, so let's see here. So we know that for all of us, we know that this is an actual article. Oops, I don't know why I did that. Okay, so let me go on and get the code book open first. Okay, so motor fuel dispensing, we know. So if we were to go to the index, and I can do that because I do have the index. And I don't like this screen for sharing the index real quick, so let me change. All right, so here, and I go down to motor fuel dispensing. And I'm down here, and let's see here. Let's see here. Bear with me because my eyes are terrible. And let's see here. Okay, here's motor. There we go. Motor fuel dispensing right here. So the first thing we can see that this is Article 514. You might already know that. And remember, what did I say? If you know that, you go right to it, right? You're like, boom, I know this one. And you might know this because you're in the program, and you might go, dude, I know the answer to this in less than a second. Oh, boom, answer it, move on. All right, so now we're looking classifications of location. And that's what we're asking. We're trying to find what the class is of location. So immediately, I see 514.13, right? So that would take me over here to the NEC, and I would go to 514 right here, motor fuel dispensing, right? And it was .3, so I'll click on it. And here's a classification of location right here. And we see here, so, okay, all of this information here. So then we have this little nifty diagram, right? So we got all these diagrams. This is a general layout. Probably can get the most of what you need. If you were to look at this, by the way, you probably get most of what you need. But we're going to go down. So we're talking about classified locations because that's what the question was about, right? And so you look at this diagram, but if we go down to B1, class 1 locations, because we narrowed it down to that, right? And basically it says table 514.3B1 shall be applied where class 1 liquids are stored, handled, or dispensed and shall be used to delineate the classified motor fuel dispensing facility and commercial garage, yada, yada, yada. Okay. So we have all of this. Interesting. We have a table. And I don't know if this will pop out. Okay. Pops out. Looks okay. All right. So what are we doing? Our question said the area of our motor fuel dispensing facility within 18 inches of the finished grade and 20 feet from the outdoor gas pump is a blank location, okay? 18 inches above finished grade, and it's 20 feet from it, okay? So let's see here. Here's where dispensing device, and it's a tank. Just want to see where we're all at with this tank here, okay? Remote pump, okay? And so let me see if I can pin the top real quick so this doesn't look kind of somewhat goofy in the way that it's laid out. Okay, so here we see here dispenser and dispensing. This doesn't say anything about. Okay, so under the dispenser is 1. Okay, outdoors is a 2. Okay, and let's see here. Let's go. Let me pop this up. Let me get to the image. Let me see if I can't blow this. I don't know if it'll let me blow this up. I guess it will. There we go. I guess it's kind of blowing up. All right. So here is your storage right here. Storage tank top view. And this is out 20 feet. Class 1 Division 2. All right. All of that's leading us to Class 1 Division 2. And let's see here. Let me go see if I can get another angle here. Hold on, bear with me. I'm trying to share it all in one little thing here. And it's not letting me. Not letting me. Oh, there we go. Okay, there we go. There we go. All right, so here we go. Outdoors right here. And we're kind of this line here. There you go. 18 inches above and extends 20 feet horizontal in all directions from the dispenser enclosure. Okay. So that kind of answers our question. But that's based on this nifty little table. And again, sorry, I got to scroll around on it. Screen's small, but there you go. So that's where we get that answer right there. All right, so let's get back to the Good question, the lesson. So we narrowed it down, but it's clear that it's a class 1 division 2. And there's our reference right there, 514.3b1. And we got that one, by the way, by simply going to the index. And obviously, since we identified that a motor fuel dispensing facility. Now, you could have gone to, you might just already know the go-to. John says, damn, I was close. You only had a 50-50 chance, John, and you blew it. But so that's kind of one of those ones there where we would narrow it down. We knew what we were dealing with, so we know it's a B. Here's something to think about. So the class 1 division 1 is going to be directly below the pump, okay, because that's where the fuel comes in. And then as it goes in up 18 inches, and as it goes out, then you're looking at where the issue is reduced. And as it goes out, it ends up being a division 2. So class 1, division 2, that type of thing. So anyway, there you go. Let's do another one. All right. Okay. Let's see what we got here. Now, here's a good example of a question about terminals that Charlie asks here. So I'd say termination provisions of equipment for circuits rated over 100 amperes or marked for conductors larger than 1 shall be used for conductors rated blank degrees, 60, 75, 90, or 167. What do you think? Let me know in your comments. Y'all see what it's saying? So here's the question. So let me know in your comments. And the first one that gets it right will be the first drawing that we do today. And just so you can see it, TGAI says, he says, second guessed myself off on a reference. I have more to learn. Yes. Okay. So Jonathan's given us the answer. He gives us 75. So he's the first one to answer this one over on YouTube. Okay. So let's see here. And Daniel's giving us 75 as well. All right. Okay. And we're going to ask, I'm going to do a little bit of a discussion on this one real quick. So, all right, so I'm asking you guys a question. So these two gentlemen say 75. So I'm going to ask, where in the National Electrical Code, so first of all, Jonathan, you're going to be the first in today's drawing, just so you know. Okay, so you'll be the first in today's drawing to get a register to win. So you're already on the book, so I'll write you down. Make sure you hang around to the end, okay? Hold on, if I can get my damn pen to write. All right, so 1, I got you here. So hang around because you are correct, but I want to talk about this a little bit. And I've just started getting rid of my face on the screen because y'all don't need to see me. You can hear, as long as you can hear me, because it makes the screen a little bigger for you. So in this one here, there is a specific article and section that we go to that's going to give us this guidance. Can anybody tell me where and what section you go to get this guidance? And I'll wait. And y'all know the question, so I can come to the chat because y'all know the question. Okay. All right. Miles says driving, but 110.14. Very close. You're right there. Not the full section. Okay, not full subdivision of it, but good enough for me, Miles. So you'll be the second drawing for today. Okay, and so that type of thing. So let's kind of look at this one real quick as far as the NEC goes. Okay, so let's kind of go. So the first thing that I think about when I see that question is it's asking me about termination provisions. And so we're familiar with 110.14, and C is going to give us the different things for if it's 100 amps or less, it's 60. If it's over 100, it's 75, and that type of thing. And of course, it tells us when it's 1 and larger, or larger than 1, then it's going to be 75. Okay, so let's go look at that. That's at 110.14. Those are your limitations here. So 110.14. Remember those are your electrical connections. So 110.14. This is also a good one that also explains the use of antioxidant compounds. I get this question an awful lot. Since we're here, we might as well talk about it, right? So close, TJI, but you're missing a letter in there, and then the 1A. There you go. You caught yourself. All right. So look, antioxidant compound is not a requirement. If you want to use it, that's great. Manufacturers of wire and cable are not going to demand you use an antioxidant compound. We're not. If you want to use it, that's great. If you feel like historically you've used it and that's just the right thing to do, you boo, is what I say. Will we as a manufacturers of wire and cables support the use of antioxidant on aluminum? Absolutely. If you want to do it, whatever preserves the life of the conductor in whatever environment you're installing means less issues for us. We're all about it. That's why the ampacity of a conductor is very conservative based on the insulation, which probably could handle more current, but we're okay with it because it protects our conductor, and it protects the manufacturer, and it's historically been okay. There are jurisdictions where AHJs will demand that you use an antioxidant compound, for example. That's their own imposing their own will. It's not a requirement of the code anywhere. It could be part of the listing, could be part of the manufacturer's equipment. It could say right on it to use antioxidant compound with aluminum. If that's the case and it's part of the listing, you use it, right? But it's not something that is required. Now, you notice the reason for that is at terminations, because that's where we're at, 110.14, you see the words I have highlighted. It says materials such as solder, fluxes, inhibitors, and compounds. Notice those words, where employed. Those words that say where employed is where you choose to use it. Okay, or where it's required from the manufacturer. The wire and cable manufacturers do not require it. Okay, so where employed, it shall be suitable for the use, means it's got to be designed for the right material. It can't be detrimental or have an adverse effect on the conductors, on the installation, on even the equipment. Some manufacturers' equipment will tell you they don't want you to use an anti-oxidation compound that has petroleum base in it, that type of thing. So you'll have to look for alternatives and stuff like that. But most of the ones today are some type of petroleum base that locks out moisture from getting in it due to that. But just remember, it's not a requirement to use antioxidant compound on aluminum, no more than it's not a requirement to use it on copper. But both of them will oxidize. One just does it at a higher rate than the other. Now, if you torque a conductor properly and you torque it down, then you're removing the ability. Immediately after you strip it, and you torque it, then what happens is you remove that oxygen content at the contact points and you have a less problem of breakdown because you torqued it properly. But if you're not torquing things properly, you're not following the rules for torquing in 110.14D, for example, or per the manufacturer instructions, then you could have a problem. Now, what is our recommendation for places like on the ocean, right there at if you're on the ocean front where there's a lot of salt water? Then antioxidant compounds can be, not a requirement, but can be beneficial to the longevity of that termination if you're not going to terminate it properly with torquing. If you're not going to follow the torquing rules and things like that. A little oxidation on like an aluminum conductor is not a big deal. It is a big deal at termination, but it's not a big deal if it gets on the ends or if it gets on the conductor itself. It's not that big of a deal. Okay, it basically it forms a protective layer, but it's that contact that we're worried about. Metal to metal contact for conductors. That's what we're worried about. That oxidation becomes like an insulator. Okay, so that's what we're really worried about. So again, don't let anybody tell you that antioxidant compound is required, but AHJ might want it. And is that worth an argument? Probably not. If he's like, I gotta have antioxidant on aluminum. Okay, I'll do it for you, unless you really want to pick a fight, that type of thing. Okay, anyway, sorry, I went down that little rabbit hole, but I wanted to explain antioxidant compounds, and again, a lot of myths online about that. Okay, so now we get down to the terminations, all right? So here we're at 110.14, and there's A, and there's B, and then there's C. And of course, our question is dealing with what? We're dealing with the values with 60, 75, 90, or 167, okay? So when you get down here, it says the temperature rating associated with the ampacity of a conductor shall be selected and coordinated so as not to exceed the lowest temperature rating of any connected termination, conductor or device. So remember, Charlie, when I was talking about it earlier, 9-degree insulation for adjustment and corrective purposes is great. Can I use the 90? Sure, if the lugs are rated for 90, then I can use that value, that type of thing. Okay. At the end of the day, we still have to protect the conductor at its ampacity. All right. Now, it goes on to say conductors with temperature ratings. All right, listen to this, folks. Conductors with temperature ratings higher than specified for termination shall be permitted. So this is what allows me to take, let's say I have a 60-degree termination. Can I use wire with an insulation that's rated 75? Absolutely. Can I use wire that's rated 90? Absolutely. Now, weakest link means I can't exceed the value at the 60 even after adjustment and corrective purposes. But can I use that insulation even though it has a higher rating? Absolutely, I can. It's just better insulation. It has a higher heat protective value on it, right? Okay. All right. But it says conductors with a higher temperature ratings higher than the specified for termination shall be permitted to be used for what? Ampacity adjustment, corrections, or both. So this is what gives us, everybody asks, where do we get the permission to use the 90, even like with non-metallic sheet cable for adjustment and corrective purposes? Because NM cable, the conductors inside of it have a 9-degree rated insulation. This is where we are able to use the 90 on a conductor, if it's rated 90, for adjustment and corrections, even if the end ampacity can't exceed the 60-degree, because it's less than 100 amps, let's say, we can still use the 90 for adjustment and corrective purposes, okay? That just doesn't mean we get to use all the amps available, that type of thing, okay? We just get to do it to make sure we still have a conductor that's good enough for the task based on the limitations of the 60-degree, let's say. All right, so anyway, down here, it says, the determination of terminal provisions of equipment shall be based on 110.14C1A or C1B, unless the equipment is listed and marked otherwise. So what does that mean? That means that if I have a termination and it tells me in here that it can only be 60 if it's under 100 amps, then it's got to be 60 amp column ampacities. That's okay. But if, like what Charlie was saying, if my lugs are rated 90, if my wire is rated 90 and my end equipment lug is rated 90, then even if it is under 100 amps, I can say, screw all that. I can use the ratings of the terminations as long as everything is the same, okay? When any one of those are lesser, then I have to follow the weakest link concept, okay? All right, it says conductor ampacities used in determining equipment termination provisions shall be based on 310.16. So that is your base rule ampacity table, 310.16, okay? All right, so here's the first one. Termination provisions of equipment for circuits rated 100 amps or less and marked 14 through 1. That's not what our question was, okay? Our question was what? It wasn't, but it's larger than 1, and it was rated over 100 amps, right? So I had to jump down here to B. So the terminal provisions of equipment for circuits rated over 100 amps or marked for conductors larger than 1 shall be used only for one of the following. So you have your choices here, right? Conductor used at 75 degrees C, 167. Okay, so now let's bring me back to the question. Why didn't I choose? You're probably thinking, and I get this email from people in our program. They go, why wouldn't 167 be the answer? Right? Because in exams, we always default. And in this case, it says C. See here? Let me take you back to the question. In this case, it said C. Right here. Even if this hadn't said C, I would have still defaulted to the 75 because that is the default when it comes to exams is C. Okay. Be careful of that. This one just happened to tell you the C is stuck it down here, so obviously that says there's no way it can be this. Okay, so the only right answer is this one. Okay, and there's your reference right there. That makes sense? Okay, now that was a long way around answering that question, but the reason it was is because I wanted to explain how 110.14c works. Okay, now the last one that you focus on this one, I want to get off of this, but I use this question as a lesson. The last thing I'll tell you about this is that I want to remind you of something that you do every day of the week and you don't realize you do it, even when you're dealing with something that's under 100 amps, okay? And that is right here. You typically will use this provision right here, number 3. And that is where it might be under 100 amps, okay? And it might be 14 through 1 gauge. However, it says with the conductors with higher temperature ratings, if the equipment is listed and identified for use with such conductors. What that means is that you can ignore the limitations of the 60-degree column if your conductor, your terminations, and everything is rated 75 or greater. So if I'm still under 100 amps, now this doesn't work for non-metallic sheath cable because 334.80 tells you no matter, you can use the 90 degree rated ampacity for adjustment and correction, but you're not going to exceed that of the 60. Makes it clear in 334.80. But in other areas like MC cables and things like that, the conductors, it's one of those things that if it's 100 amps or less, and let's say its size is 14 through 1, but if the conductors are rated 75 or higher, if the terminals are rated 75 and the equipment on the end is rated 75, even though it's less than 100 or the conductors are 14 through 1, I still am able to use the ampacity in the what? The 75 degree column. And you do that every day of the week, whether you think you do or you don't. You do it every day of the week. The only limitation that you don't is when you're dealing in things like non-metallic sheath cable, where it says, I'll let you use the 90 degree rated ampacity just to adjust and correct it to make sure that you still have enough, 1, to handle the load, and 2, you're not going to exceed the value that's in the 60-degree column, okay? So all we're doing is adjusting it to see whether we still have a conductor that's good enough to handle the load. That's all we're doing, that type of thing. And if that adjusted ampacity ends up falling below the value in the 60-degree column, what does that mean? That means we're going to have to jump up in the size of the conductor, that type of thing, that scenario, all right? Okay. That was that one. I just want to do a little lesson today on conductors and ampacities and that type of thing, just so we could kind of have that little discussion. All right, next question. Circuit conductors other than service conductors. Let's see. Circuit conductors other than service conductors shall not be permitted to be installed in the same blank or service cable. Okay, so it's the same service raceway, enclosure, control cabinet, or dwelling. What do you think on this one here? You're thinking, okay, well, so in this one, since it's talking, let's see your comments, guys. Be sure to interact. Circuit conductors other than service conductors. So it's talking about services, and it's talking about intermingling or mixing of whether or not you can have service conductors and other type of conductors in there, like branch circuits or feeders and things like that, right? That's what it's looking for, to see, okay? But at the end of the day, remember, raceways can be wireways. They don't have to be a round raceway, okay? It can be a wireway, it can be other things like that, so kind of keep that in your mind, okay? So is it only going to be limited to enclosure? Is it going to be limited to control cabinets? Is it going to be, what does this have to do with dwellings? That type of thing. Because we do have panels that have both service, feeders, and branch combined in an enclosure, right? So we see that every day, right? In your main service that comes into your house, in your panel. Don't you have service conductors in there, in that enclosure? Don't you have feeders potentially in there? Don't you have branch circuits all in the same enclosure? Yeah, okay. First off, dwelling makes no sense. Control cabinet makes no sense, so I'm narrowing it down. So when I think of enclosure, just let your mind think, wait a minute. that in my mind, I'm thinking, I can obviously have service conductors in an enclosure. Okay. So thinking of that. So this is a service related type of question. Okay. So first thing that I might go to, if I was going to go to the index, all right, then I might go to the index and I might, hold on here. Index is not loading for me. Yep. Let's share this tab. Then I might go to the index and I might go under services. Okay. We'll do a little, a little bit of index work today. All right. So this might be where you go if you look at that question. Or service conductors, probably. So we'll look under service and see what we got. Bear with me. Okay, here's S. And let's see here what we've got here. And I'll get y'all. So we have service cables, service conductors. See, conductors see service. Okay, so conductors see service, but I'm going to look while I'm here. So service inch conductors, service inch conductors, it's 230. Okay. And we're talking about service conductors. So I want to look down this as I look down real quick. Okay. Right here, service raceways. Oh, there you go. Conductors, other permit. Oops. I can't even see it. Let me see if I can go bigger. There we go. So here it's service raceways. Okay. So conductors, other permitted, 230.7. And somebody said, is there another location? No, it's not another location. Anybody see another one? Is there another one somewhere? TJI says, I see conductors, others permitted under. Okay, so y'all are in the same one. So y'all are right here. There you go. So in that one, you'd have to know, dissect it and say, because it doesn't say that anywhere. So that's using the answer for that one. Great. Yeah. So y'all are using the answer to get you that one. Well, there you go. Good. There's another way. So that's why you want to, for me, I don't have to use the index for me because I know what the answer is. And if you're in the fast tracks, you knew what the answer was. And you've probably regurgitated this to people a million times. Don't put service conductors passing through, okay, a service raceway or a service wireway, which is a raceway. So you don't intermix those things, right? But that just example. Oh, and another tip. I'm just show you. Tests are, using the index can be difficult. That's why you want to spend time in it. So that's why we spend time in it. That's why I tell you, if you get a good set of questions, don't be afraid to spend 20 minutes, 30 minutes dissecting a question and looking in the index for all the possible answers. That's how we do it. And y'all did it. And hell, I didn't even see it. So, but there's going to be certain things on an exam you already know the answer to. And you're going to be like, answer it, whoop, whoop, answer it, move on, and don't have to worry about it. That type of thing, okay? What is Charles? Charles says, my local test requires a reference all questions in the code book, so the index helps. It does help. Index always helps, but it's not the holy grail, okay? Nobody go into a test not preparing and think that you're going to be able to nail it just because you're really good at navigating the index. You have to sit there and really take time to go through it. The text is real small. I recommend a ruler, if they let you take in a ruler, so that you can use a ruler, especially if you're working on tables and stuff, and do it that. So again, let's do some giveaways first. All right, so let's go to some giveaways for those that are still here. For those that left, too bad, so sad. All right, we're going to do some giveaways here. All right, let me get rid of this screen. Okay, if you're still here, Jonathan, I didn't forget you, so we're going to take you into the drawing, and we're going to spin the wheel and see what you get. Oh, by the way, what we're giving away is you can either get a free estimating software, Next Gen, which comes courtesy of Best Bid Hybrid. So that is going to be a drawing on the 31st of March. You can get an exam, a bidding course, which teaches you everything you need to know about bidding. man hours, breaking it, all this kind of stuff is well worth it. That's an over $500 value. That'll be drawn. And we're making a list. And so if you win an opportunity to be in the drawing, you'll put your name in the drawing and we'll draw it out. And we'll do that live. Let's see here. What's that? Oh, we're giving away a 2023 grounding and bonding course, a 2023 exam prep enhanced course, a 2023 mastering the NEC course. Tomorrow I should be announcing what other things we're adding to the wheel from the engraved catalog, in case you want like a minimalist wallet or one of these coins, that type of thing. So we're looking at that. I should have approval on that by tomorrow. And what else are we giving away on that thing? Oh, you get a year's of Fast Tracks tube. You can win that instantly, that type of thing. All right, Jonathan, if you're still here, we're gonna spin the wheel and see what you win. Magnifying glass. Yeah, and if I went today, I would definitely have to take me a damn magnifying glass in there. I can't see squat, and I can barely see my screen, and y'all can relate if you ever worked off a screen. My index is a little screen over in the corner. I'm sharing it with you magnified, but my view is still the teeny weeny view. So I can't, I'm having a hard time. So again, just learn your index, take your time, work your questions. You'll be surprised. There's probably many of ways to find the answer in there. Okay, let's spin the wheel, Jonathan. All right. Jonathan, if you don't have a Fast Tracks Tube account, it's an annual subscription over on Fast Tracks Tube. Go over there and sign up for a free membership, and then we will elevate you to the annual subscription, and you'll get access to exclusive videos, other things, another webinar that's coming in the summer that's going to be only members of Fast Tracks Tube. We're going to have access to it. It's not going to be on any of our other channels. You'll get access to that. And so there you go. And you can get the 8-hour calculation series. You can get the webinar we did on Raceway Phil, all those type of things that are only exclusive to people on Fast Tracks Tube. If you want that, go ahead and do it. So I'll put you down as Fast Tracks Tube. All right, next is, I believe it is, I said it was going to be Miles. Let me go back and make sure. Yep, Miles. All right, I think that's Miles. All right, ready, Miles? We're going to give you a drawing. Let's go. Get a year subscription on Fast Track Tube. If you're already a member, we can extend you to another year. Or if you don't want it, you can tell us to gift it to somebody, and we will spin it. We'll ask a question, and we'll give it to somebody else. So if you don't want it, but again, Miles, go to Fast Tracks Tube, register for a free membership, and then we'll elevate you up to the annual, and you'll get access to all the stuff that you can get. And that also allows you to get access to all of the new videos that are interactive that are going to be coming out. We have that sample that's up there, but you'll be able to get it. Okay. All right. So I'm going to ask a question now. And so in order to win this one, it's basically going to be the first person that gives us an answer. Okay. Says, Paul says, do not answer too fast because he might give you another option. Not sure what that means, Paul. I'm not sure what that means. Tell me what you mean. All right, so I'm going to ask you a question. What is the value for K when doing a voltage drop calculation for aluminum? First person that answers. I realize there's a delay. The first person that answers gets to spin the wheel. Kind of refresh what we did tonight. So again, it's be on the screen, and all right, Dominic, 21.2, absolutely. All right, Dominic, you get the spin, see what you can win. Colby says 21.9, close, 21.2. I think you're thinking 12.9, got those numbers inverted. are for copper. All right, so, but it's 21.2. Okay, so let's see here. Let's see here. Bear with me. I get my thing straight here because I got thing is screwed up. Okay, so let's go to spin the wheel. Oops, you were close. You were close. All right, let's see here. We are going to be doing this for Dominique. Let's spin this wheel for Dominique. Dominic, have you won before? No, Paul has won. Miles is first time. Jonathan, that was your first time. Okay. All right. Dominic, you are entered into the drawing for the 2023 NEC Enhanced Exam Prep course. Okay, so I don't know if you already have a program, Dominic. What program do you already have? But you're enrolled in this one, okay? Everybody's saying 21.9, 21.2 for aluminum, 21.2. All right, Dominique. Now, you already have this, Dominic? Are you already in the 2023 program? Because if you are, I will give you ability, we'll spin again if you're in it. You're in the black. Okay, so black, that one expires. This one doesn't. So do you want to stay in the drawing for this 2023 one? That one is the most relevant code at the time. It doesn't expire. You want to stay in that drawing? As you are current black, but then we can just, if you happen to win, we'll move you over to the enhanced one. Like that. All right, so let's do one more, participation. And I'm gonna go through with participation and look and see here. Look at the numbers. All right, TJI, a lot of participation today. So TJI, yeah, okay, staying in the drawing. All right, good deal. It's a good deal for that one. That's much better than the black or the pluses. So stay in there. Okay, so TJI, we're gonna draw for you. Let's go. I think you have one before. You got an F Fast Tracks tube, you gave it away. You are in the best bid hybrid drawing. Okay, maybe you'll get another entry into that. Let's go. The NEC course, which is not an exam prep course. This is more like a consulting course, same content, but it doesn't expire. You can use it, interact, you can upload pictures, images, ask questions, but this is the post licensing course that we have. So we'll put you down, TJ, unless you don't want it. Although you can gift it to somebody if you want, or you could say, look, I'd rather give it to somebody else if you're interested in, this, but this is the post-licensing course we have. Right? This is more consulting, more of a, not really it's designed for exam prep, okay? TGI, can't put you for that one because you won this one. Now, I will do this, and I'm a rarity on this. Do you want to spin again? I'll let you spin again. If you don't want this, I don't usually do this, but I figure, what the heck? I'll let you spin again. You want to be in this drawing for this course, or do you want to spin again and take the chance? But it's one and done, so whether you get it or not, whether you get the fast interact again, you're done. So do you want to stay in this, or what do you want to do? Miles, yes, you can. Yes, if you have it, just tell that person to go and register at Fast Tracks 2, and then you send me an email telling me his name and information, and we'll elevate him. Absolutely. TGI says, I'll take it. All right, so TGI, you are registered for the 2023 Master the NEC course. Okay, that's a post-licensed. That's a nice one. It never expires, and it's great for using out in the field. Okay. All right. We'll do one more based on a question and see who answers it quick enough. I hope that music isn't too obnoxiously loud. All right. Now, again, based on the information we learned today, get ready, texting, get ready to type it in. I know there's a delay some places, but the last one, you ready? Okay. Let me get this down real quick. Okay. All right, you ready? What is the maximum number of current carrying conductors that we can put in a raceway before we have to do an ampacity adjustment? What's the maximum number of conductors in a raceway, current carrying conductors in a raceway, before we have to do a adjustment for the ampacity of those conductors? What's the maximum number before? Boom, 3, Jonathan. Jonathan got us. And that is correct. When you have more than 3 current carrying conductors, you have to do an adjustment, okay? So 3 is the maximum before that adjustment kicks in. Jonathan, you won again, so we're gonna spin you again and see if you can get registered for something else. So let's go, but everybody jumped in. Val was in there. Paul was in there with 3. Jonathan got in there first. And it goes to show you that maybe the YouTube is a little quicker on responses. What do you think? All right, Jonathan, let's spin it. So we're going to spin you again. Unless you want to gift it to somebody. There you go. I'm generous today. Jonathan, is there somebody you know you want to gift this to? Kevin's coming in late. That's a delay on that platform. What is he on? He's on YouTube. All right, Jonathan, gift it. Is there somebody you want to gift it to in your company or that you know? Or do you want us to give it, pass it on to somebody else that's in the group? Okay. Jonathan says gift it because he's already got one. If he wants to gift it to somebody, does he want us to do somebody in this group? Or does he want to have us me pick one and give it to and let somebody else go? Because this is the last one we're going to do. Okay, I'll pass it. Okay. All right, so I'm going to ask another question. So this is going to allow you folks to get involved. And the first answer is going to get the spin, thanks to Jonathan's gifting it. All right, so let me go back to the chat. Let's see here. All right. TGI says, on my end, they were already throwing out answers before you asked the question on Fast Tracks Tube. So it's a late Fast Tracks Tube. Okay, so we'll go with this one. I'll go through gifting. We'll go through participation because there is a delay on Fast Tracks Tube, so that's probably not fair. So let me go through real quick and look at my thing and let it look at participation. Okay, participation, it's drawing, and I don't know if he's still here. It looks like, what's his name? David Carter. All right, David, it's bringing up David as participation. I don't know if you're still here, David. Don't have to be present. You just have to be there for the drawing on the date on March 31st. All right, so let's spin the wheel for David. It was gifted by Jonathan. So I'm probably going to stick to participation. Or I think there is a feature that I can add that allows you to interact, click. So I haven't turned that on. So it's a gamification feature that might be able to even use during the lives, that type of thing, okay? Yeah, I wish there wasn't so much of a delay on the Fast Tracks too, but our engineers can't figure out how to get it so tight. So anyway, let's give here. David, let's do this one for you, David. Give it away. And David Bueno, he said, David Bueno said, damn, I almost thought it was me. All right, but let's go here. David Carter. Don't go anywhere, Bueno. All right, David Carter, if you're still here, you're getting a chance to win the bidding software. Okay, so this is the best bid hybrid bidding software. It's almost a 4,000 or might be over. I don't know the current price of the next generation, but you're in the drawing to win that software. Whether you want to get into estimating or whether your company needs a bidding software, you can obviously win it and sell it and give it or whatever, but that's the biggie. So I'm going to put you in here. So you got the bidding software. You're in the drawing for that. Okay. All right. We always use the latest edition, Kevin. The 2023 is always the latest edition of the NEC we use. Always do it. There's no way I can cover all those different cycles. So we're always going to be on the latest edition when we go to questions. Okay. All right. David Bueno, it's your lucky day because that comment got you a spin. So let's go, David Bueno. Let's go. You never know what we're going to pick. All right, 2023 NEC Grounding and Bonding course. So David, you're registered for the 2023 Grounding and Bonding course that we have. Great reference. Everybody should know grounding and bonding, and that is probably the best course on grounding and bonding out there. And a lot of great illustrations and that type of thing. So you're registered for that. The drawing is going to be on this date. And so we will try to do it live. And that way you can see names picked out of hats, that type of thing. Luis says, what the hell is going on? Well, you got to get here at 8 a.m., Luis. So what we do is we do a show, coffee hour, let you talk about electrical. We do some exam prep. We talk about things like I talked voltage drop today a little bit. And then at the end of the shows, we spin the wheel, and based on your participation in the show or maybe some random questions that I ask, then we select you. If you hang around enough, your name will be selected. Okay, so if you miss out this time, you know, because Adam's asked this before. No, because if I do that, it means that it's going to be small. And I have to make it big so you can actually see the freaking questions. If I try to break it out and make it smaller, I can't, the question gets reduced down so small you can't see it. So it's better for your mind to read that question, dissect the important pieces out of it, just like you would on an exam. And then when we go looking it up, you got to remember those pieces. Just like you do when you're working in an exam, you got to look at it, pull out the key things when you go to the index, and then you use the index and that type of thing. So, but physically, it's the real estate on the screen makes it hard for me to keep that question up there because we're using the database, okay? So it makes a little harder to do that. But I do appreciate that, and I do know that, again, you're just going to have to, you know, the question, that's why I go back and forth to it a couple times, but really, you want to lock in the key pieces, that type of thing. You know what I'm saying? All right, folks. Enough of Jeopardy. To me, y'all might like that, but for me, it gets old. All right, so David Bueno, we got you in. So the winners today, Jonathan, Fast Tracks Tube, go register. Miles, Fast Tracks Tube, go register. Dominique, you're in the 2023 Enhanced Drawing. TJI, you're in the Mastering the NEC course, the post-licensing course. You're in that drawing. David Carter, you're in the drawing for the bidding software. Okay. And then David Bueno, today, you're in the grounding and bonding course. And again, we only try to do about 5 or 6 a day. If you didn't get it today, you probably got it yesterday. Come back. We will make sure we keep track of everything for you so you don't have to worry. And your name, if you win something multiple times, then you'll get multiple entries into that. So it's not just one entry, right? So it increases your odds of winning, that type of thing, especially things like the bidding software and all that kind of stuff. All right, folks, that is going to be all for today. I went over a little time, so I want to be good stewards of your time. And then we can't call it coffee hour when Paul always is more than an hour. I'm always more than an hour. All right, folks, I appreciate you all. Hopefully you got a little something. Hell, if, you know, at least if you had a chance to get your juices flowing, enjoy the code, have a little coffee, share with me anything. Remember, You can share just about anything you want in here, and we'll talk about it. Maybe you have an issue at work, or maybe you want a recommendation for this, or Paul, which's better to use, THHN, THWN-2, or XHHW in a Raceway Underground? Maybe you got that kind of question, or maybe you want something like that. This is an open forum. Now, if the code gets really technically deep, then I might say you need to go to paulabernathy.com and submit it so that I can give you a more detailed response. But at the end of the day, keep practicing that index. As you can see, even these old eyes can't see it. You might find the answer to a question 5 or 6 times in the index. You just got to keep looking around, take your time, and use it while you're studying. You don't have to worry about timing yourself if you're taking an exam. Don't worry about timing yourself until you get down to the last 2 weeks. Then you can use your phone with the timer, and you can set it up on there, and you can answer each question individually with a 2-minute timer. And then that allows you to be able to slow down and really focus on how long it took you to answer that question. Okay? And that's going to show you how much better you have gotten over time when it comes to exam prep. All right? All right, guys, thanks for joining me. It's a great cup of coffee. I always love joining y'all to get my day started. Take care. God bless, and we'll see you tomorrow.